Hi guys, welcome to Memo's tutorials. Today we are looking at group properties. On these group properties, we are going to focus on the group 1 elements, group 2, the group 7 and the group 8, which we call the noble gases, or the group 0 elements. Okay, so what I want you guys to take note of is that the group 1, we call them the alkali metals, and group 2, we call it the alkaline earth metals. Group 7 are halogens. These are very colorful gases. And then group 8, we call them the noble gases. They are rich, these ones. They have enough electrons in their outer shells. They are full and stable, right? So starting by looking at the group 1 elements, we need to know its properties, the physical properties of group 1 elements. So these ones, they are soft solids, they can be easily cut, and their softness actually increases down the group, right? Meaning to say, as you go down the group, they actually become more and more softer. And they are gray solids. They are usually gray in color, and they also have a shiny silvery surfaces when freshly cut, and turn dull when exposed to air because they are very reactive. Take note of that. Yes, they are gray, silvery, shiny, but once you cut them and you expose them to air, they quickly get dull. Why? Because they are very, very reactive. They will react with air, right? And then when you're looking at their boiling and melting points, they decrease down the group. And then they have low densities, which increase down the group as well. They are good conductors of heat and electricity. I'm sure you still remember that metals are very good conductors of heat and electricity, right? Since these alkali metals, they are metals as well. And then on the chemical properties, these group 1 elements, they form ionic compounds in which the metal ion has a charge of +1. All group 1 ions, they will have a +1 charge, which simply means they just lost one electron to the other. Remember, the ionic compounds, there's donation of electrons, right? So these group 1 elements, they'll be the ones donating electrons to the other element that they would have reacted with. And when it comes to reactions with water and chlorine and oxygen, they react violently. Take note of that. They react violently with chlorine, with water and oxygen as well. And these group 1 elements, they produce soluble white compounds which dissolve in water to give us colorless solutions. They produce soluble white compounds which dissolve in water to give us colorless solutions. That's very important for you to note on the group 1 elements, right? And also they become reactive as you go down the group. Why? Because the valence electron, so it is lost more easily due to less strong force of attraction. I'm sure you can agree with me. When talking of hydrogen, we're just having one proton and one electron. They are very close to each other. But when you compare it to sodium, the last electron on sodium and the nucleus, they are far from each other. But then when we are looking at hydrogen, the electrons in the nucleus, they are close to each other. Because they are close to each other, it makes it so difficult to break their bonds, to break them apart so that they can take part in the reaction. But then if the electrons are further away from the nucleus, it means less energy is required to break them apart, and they will react easily. That one electron will be easily donated. That's why reactivity increases as you go down the group. Okay, that's for group 1 elements. Now we are moving on to the alkali earth metals. These are group 2 elements, and the physical properties of these group 2 elements is that they are also shiny, silvery white metals that are less metallic in character than as compared to group 1. They are less metallic as compared to group 1, right? Also, their boiling and melting points decrease down the group, but then they also have got low densities, and it also decreases as you go down the group. What about their chemical properties? This is very, very important. They also form ionic compounds. They are also very reactive, but not as reactive as group 1 elements. their reactivity also increases as you go down the group. I explained the issue of reactivity, right? They also react with water, and when they react with water, they form alkaline solution, which are just basic solutions, right? And now moving on to the halogens. These ones are colorful gases. These are halogens. They are group 7 elements. These halogens, they form diatomic molecules. They always exist in their diatomic form. When it's fluorine, it will exist as F2, chlorine Cl2, bromine Br2, iodine I2, right? Their boiling points in these ones, they increase as you go down the group. They form colored gases. Fluorine is pale yellow, chlorine is a green gas, bromine forms a red vapor, and iodine a purple vapor, right? So it's like the color gets darker as you go down the group, starting from yellow, green, red, purple. It gets deeper and deeper as you go down the group. And these ones, they are nanometals, and they do not conduct any electricity and heat. And another thing, these gases, they are very poisonous, they are toxic, and they are not metals at all, right? And their density, it actually increases as you go down the group. So now, what about their chemical properties? So when we look at the chemical properties of these halogens, the group 7 elements, number one, these halogens, they react with metals to form what we call halides. When they react with the metal, we form what we call a halide, and they are very reactive, and their reactivity decreases as you go down the group, which simply means iodine is less reactive compared to bromine. Bromine is also less reactive compared to chlorine, and chlorine is less reactive compared to fluorine, right? So now, why is it their reactivity decreases as you go down the group? It's because the smaller the atom, the easier it is to attract the electrons, right? Remember, for the group 7 elements, they need to gain an electron, right? They just need one electron for them to be full. So the smaller it is, it's easier for it to attract the electron. The bigger it is, the more difficult it is for it to attract an electron. These ones, they form acidic solutions. And a halogen will displace a less reactive halogen from a solution of its halide, which simply means if I'm having a hydrogen iodide and I react it with chlorine can actually replace iodine, and I'll end up with hydrogen chloride and an iodine free on its own, because chlorine is more reactive than what? Iodine. Then, what are the uses of halogens? Chlorine, I'm sure you know chlorine, we use it in water purification, also for making chlorofluorocarbons, for making pesticides, we need fluorine, making hydrochloric acid, we need chlorine, bleaching agents, we need chlorine in wood pulps, flame retardants, we need bromine, refrigerants and lubricants, we need fluorine, disinfectants, we need chlorine, bromine and iodine. This makes them to be very, very useful, right? What about the group 0, group 8, the noble gases, the innate gases? What's up with them? So these are nanometal. Okay, it's a nanometal group, and they exist as colorless, which occur naturally in air and are insoluble in water. Take note of that. They are insoluble in water. They have low melting and boiling points, but then their boiling points and melting points, they increase as they go down the group, and they have low densities, which increase down the group. Their densities increases as you go down the group. These ones, they exist as monoatomic molecules. Monoatomic, it simply means they are the opposite of the fluorines, and where the halogens, where we say the halogens, they exist as F2Cl2 Br2. So they will just, if it's argon, it will just be Ar. if it's neon, it's just going to be Ne, right? And then now they are unreactive because they've got full outer shell. Take note of that. They don't just react, they are full and very stable. This makes it much easier for us to make use of them. They are safer because they are less reactive than anything than any other elements, right?